Hi guys, welcome back to my channel. Today we are going to discuss about the flags that we use in the microprocessor. So let me go directly into the topic, that is flag. So the definition of the flag is like a flip-flop which is used to indicate the status of the operation, that can be arithmetic or logical, as we can see here. So the definition goes like this. Actually there are five flags, and the flags are the 8-bit. So the the way of arranging the flags is like this. So these are the five flags and their short form. This is yes, means sign. We will discuss this all later. First of all, let me go to the configuration how we put the five flags in the 8-bit. So first of all, let's start from here. As you can see, this is a carry cy. And then it will start like this from the D0 to D7 in the pin, and this is a place for the carry. So if something happens, if something's in the operation happens and if you have to put a carry, then we will put the value of the carry here. In the same way, this is parity and this is auxiliary carry. This is 0 and sign. We will talk five of them about later. So let me go directly. So first of all, let's talk about the sign, which is yes, which is in the D7. Actually, I'm just pointing it as a D7 from D0 to D7. They're 8-bit. So this flags is set when the MCB of the result is 1, indicating the negative sign. So if we have the operation that we do, if we do addition or subtraction, yeah, okay, no problem. Yes, so obviously subtraction. And while doing subtraction, if we will get a negative value, then we have to put the sign negative. So for that, so that will be the status of that operation, right? And the status is negative. So for that we need a sign. So for that sign we need to have we cannot say directly the negative value. It's a negative value, so we have to say it was a 1. So and we will put the sign. So next flag is 0. So for the 0, if the value, if the after doing the operation, if we will get 0, then it will set the result of the operation 0 in the accumulator carry. And if the set is there is a carry operation and NS and LSB, it means if we have a value 0, then it will be 1, and that if not, then no. So let me go into the parity flag, which indicates the parity. So its parity is like if the number of 1, when we have to do some example for this. So let me say the result of our operation is 1 0 1 1 0 and 0, all are the 0. Okay, so let me count the number of 1 here. So here is 1 2 3. So we have even number of 1. So if we have the even number of 1, then it is 1. We will set the parity flag. The value of the parity flag will be 1. So it will check the number of 1 in that result, in that accumulator. So if the parity number of result, parity number is 1 even, then we have to say 1. And we have to say, it means we have to put the parity number 1. And if there is odd number 1, and we have to put it as a 1, 0. let not be confused. Okay, so if we have even is equals to 1 and odd is equals to 0, it's like flip-flop. Okay, and next is auxiliary carry. So if the auxiliary carry is I have not mentioned here. Okay, let me define. So auxiliary carry is actually we have to divide this 8-bit in the 4-bit and 4-bit. So let me say this is here 1 and 1 and 1. So we are this is one register, and we have another register, and if we are adding the two registers, and if while doing some operations, we can get the carry over 1 in this 4 D3, I mean, okay, let's say from here from D0 to D4, D1, D2, D3, D4, D5, D6 and D7. So if we will get the carry over 1 in the D3 position, then it will have auxiliary carry, and the value of the auxiliary carry will be 1, same as carry. So in also the carry, if we have the carry over 1 in the last position D7, then we have to have a 1 carry. Okay, so we don't have any space to put this 1.